How you doing, Dan?
Live.
Live. What are we closing down on December 2nd? Today we wanted to get together today and talk a little bit about the history of Hunting Beast and Hunting Beast gear, how a way of life and really a movement towards hunting a certain way, using certain tactics, and the background that Dan and myself had led us down the path of creating these products and getting us to where we are today, so we could continue to share tactics and knowledge with you guys, but also share the products that we designed. And so I think to start out with, Dan, why don't you tell us about your background and really, I think a lot of people know you for what you've done in the hunting industry and with hunting, for your tactics, how to hunt big bucks, how to get out there, but I don't think a lot of people know you for what you do for your day job, and really the wealth of experience that you have in producing products like this.
Yeah, I think most people think that I'm hunting for a living, and I probably could be, but I have a passion in manufacturing, and my background isn't just a machinist. I'm a research and development machinist, where I help engineering teams develop new products and make existing products better. So that's what I do for a living all day long.
Right.
So as a hunter, I'm focused on mobile hunting, and noticed that really nobody out there was focusing on mobile hunting. They're all building products for people to buy 20 stands and put them around, you know, instead of building one that you can take in and take out with you and building equipment like that. And it was kind of a pain because we were taking existing products and using them for something that they weren't designed for. I was using a real popular climbing stick and climbing stand that worked well, and it suited me good for many years. But I always looked at it and said I could do this better for my background, and I always felt like most people designing hunting products, you know, aren't people with my background, and that I could really tweak something into something special. And I really wanted to make something for myself, and at the time when we first started this, I was just thinking about making myself a stand and myself a set of sticks and screw everybody else. You know, I just wanted something for me. But as we started developing this and you started getting involved and we started looking at how well it was coming out, you were the one that said, hey, we need to market this and we need to really put something into this. And I think we got a special product for a lot of reasons, and I think at first glance most people don't see that. They have to actually use it to see the features, because they don't have the eye of the that we have from manufacturing, where the specific angles, the specific reasons you do things to make it a certain way.
Yeah, I agree. I think the big thing to focus on is that with any product that anyone makes, there's some sort of human purpose. When I met Dan and we first got involved talking about this, I mean, we had the shared purpose of going out and hunting, learning, and trying to shoot big bucks. I think the equipment that we were using at the time was serving the purpose that we needed, but then this conversation came along about how we could make it better, how we could build upon it, and how we could fulfill a purpose that we had.
Well, let's face it, I mean, when you're hunting mobile, you can't have sticks where the steps are always loosening up on you. Then you're bending bolts, you're constantly tightening. You can't have steps you can barely get a foot on, because you're going to be going up certain angle trees and stuff like that. I mean, or if you're putting it on a tree and leaving it there, that doesn't matter.
Right.
You know, and I wanted something rigid with no noise. And I mean, you were on the same scale as me, as we're going in and we're setting up a stand every time we go in and then bringing it back out with us. And there were a lot of faults in doing that with the equipment we were using. The equipment was great. It was the greatest there was.
Right.
But it could be better.
Right. So really we started looking at, as Dan mentioned, portability, mobility, packability. What could we do that would allow it to be maximum mobility, maximum packability, for what we were doing, for what we were using. The other thing was, as Dan mentioned, there's an element of safety in there and an element of ergonomics. How could we design it so there was the maximum amount of safety on a variety of crazy angled trees? Because a lot of the areas that we were going into, you didn't have a really nice pristine tree. It was at different angles. So how do we make it compatible with that? Which goes into how the step was designed. We'll get into that a little bit, and how the antler bracket was designed. Locking tight to the tree and allowing for a nice, secure footing as you stepped up onto your stand. And also be able to get it into a variety of different trees.
Right.
So maybe to start out with, why don't we talk about the essence of the tube? How did we come about landing on this tube design? And what were some of your specific thoughts when we first started this? Because originally, when we made these, we started out with a solid tube. And we did some engraving. You had some cool engraving on the original ones. Yeah. Big buck serial killer with a little buck on there. But why don't you talk about the thought process behind the holes that we now see in the tube, why they're oriented the way they are, and you know what we went through in that process.
Well, one of the big things about being mobile is your stuff has to be lightweight. So I wanted a lightweight stick, and I also wanted to be able to grip it, which the chamfers come in real handy for that. And it also gives a 3D effect. And the staggering of the holes gives you maximum strength and maximum lightness. And there is nothing lighter than tubing. You got 4 walls, I mean, nothing stronger than tubing. Right. You have 4 strong walls that work together. So you can take literally that little 1/8 inch wall, and because it goes all the way around, it's stronger than if you used a 3/4 solid stick of aluminum. Right. Your average person doesn't know that, but from an engineering standpoint, this is stronger. So with the tubing design, you can make it the maximum lightest and put in these holes in there as light as possible and still have all that strength.
Right. And the other advantage is so as we started playing around with this tube, Dan, through his day job connections, he has connections with a variety of engineers that he works daily with, and they'd often go over designs on other things that he's making. So while we were doing this, we were actually able to use our contacts through Dan to do the proper modeling, to look at where the various stress points would be on the tube based on where these hole placements were, and that can be 3D modeled. A lot of people don't realize that. But then in addition to that, it's taking it out into the field and actually field testing it.
Well, so from an engineering standpoint, we can draw this out, and we can expand, contract the holes, move them around, and see how the stresses change. And that's why everybody wants us to hurry up and release things. But we're sitting there just tweaking and tweaking and tweaking until it's perfect. And right now, this is perfect. And it's as light as it's going to get. I mean, people can make stuff lighter, but it's going to probably be made out of materials that don't affect well to weather, or are going to bend with certain weight stresses or at certain angles and stuff. And I think we've come up with maximum strength, maximum lightness, and still have a high quality product.
Yep, I agree. The other thing to note is that Dan being an R&D machinist and us forming a friendship through this, I worked in an area close by him, so we would often talk throughout the day. As some of the R&D was being done on this, we'd pass by, we'd talk about how hunting was going, but then we'd also talk about the next version of the prototype that we were working on, and we'd take it into the field and test it. So in combination to that engineering, there was literally probably about a 1.5 to 2 year process where we were using these every day in the field.
Yep.
And through that process, you know, you run into things tweaking, things bending, and you go back and you redesign and engineer. But then again, that really contributed to this final product that we have now.
Right.
So I think that covers really our thought process behind the tube.
Yep,
and
exactly.
why we landed. And as Dan mentioned, if you look up on the tube as it lays against the tree, you do get a 3D effect. Because of the way that these holes are oriented, you can look through it and it'll take on the background of whatever is in it, which is sort of an added side effect. The other thing we realized is from a packability standpoint, we often use bungee cords to strap these together. We started noticing not only, as Dan mentioned, they could grip easier, but you could hook bungee cords and other stuff on these things really easy.
Attach things to them.
Yep.
You can bungee your camera arm to them when you're packing them in. All kinds of stuff.
Yep. There's so
another thing too about the round holes is a lot of people are like, well, why didn't you give us like a 3D image, like cut a 3D hole? Well, you do that and you lose your strength.
Yep.
Round is stronger than a square. The corners in any kind of angled hole are breaking points. Round is real strong, so we're able to take more material out with the round holes.
Yep. And why don't we talk about, because we didn't cover it, but why do we have the length of this tube? The original standard tubes are 24-inch tube with a 22-inch instep. Why don't we talk a little bit about how we landed on that length and that instep?
Well, that really comes from testing it with people from short to tall. We started out with a friend of mine who's actually 4'11". He's real short, and went to real tall. And basically, the way they measure on like a stairs, I mean, if you go by a wall and you lift your foot up, you can't lift your foot up that far.
Right.
Right, and you think, well, that's too far. But if you put your hand on a step, you hook a step up, you put a hand on there, and you lift your foot, that is the step distance that you can step easily.
Right.
And a lot of people don't get that. But that is the maximum step for a short guy. And we had even some of my friends, I mean, we're getting up to an age, some of them have problems, they got knee replacements and stuff, and this was a size that almost all of them could use, except for ones that had more severe problems.
Right.
So I went with the longest we could use, so that we could get as much height out of a set of sticks without adding middle steps. Because now if we put a middle step in this, we have to beef this up because now you have a stress point.
Right.
So, and you have added cost. So the 2 steps was the idea, to keep it there, but have maximum step distance.
Right. And it goes back to kind of fulfilling that purpose when we first started doing this, as Dan mentioned. We had equipment we were using, but the goal was is how do we make equipment for us?
And really, when you say that, my sticks were what?
The original sticks were 26 inches long.
You're right, because they were built for me.
Right, right. So it was a process of elimination of finding that middle ground and then doing some research on what the average stride length is, you know, for people. That's in that 20 to 26 inch range, a walking stride length. So then by looking at that, we landed upon that 22 inch step range, which still remains to be our most popular length. We do have sitting here, and we have in front of us our mini sticks. You know, this again is it's a 22 inch length on the stick with an 18 inch step. So again, some people prefer these, but
So now, if I can say something about that. Now, when I first built these, I was kind of like, nah, I don't know. Everybody wants the short ones now, and
yeah.
I really like the long ones. But what I found was, number one, in the stress models, these are much stronger than those.
Right.
And number two, I was thinking about getting maximum height. There really ain't that much of a difference.
Yeah.
There's like, what, 4 inches per part.
They're 4 inches.
So now if you have 4 sticks, that's only 16 inches difference in height that you're getting. And, you know, because you still stretch them out just the same distance
You're
apart.
stretching them out the same distance.
So really, after using these, I'm really starting to like these a lot more personally. Even though I started out thinking I would really prefer this.
Yeah.
After using these, I like these a lot more.
Yeah. And I think we get a lot of questions about standard sticks versus mini sticks and climbing distance. I think what you'll find, because of what Dan mentioned, is how you distance these between each stick, you're going to find that it'll sort of alleviate the length difference as you go between. So then it just becomes a personal preference. You know, we have some guys that hunt with them that they like 3 standard sticks because that gets them to the heights and the lengths that they need. Other people prefer, I like a little bit tighter spacing. I might go with 4 mini sticks to achieve that same height, and it's...
And me personally, I always like having 5 sticks with me. However, most often I don't use 5.
Right.
Most often I use 4 or 3, but when I want to get that height, I want it. You know what I mean? You get in a situation where that's the tree you need to be in, and that's where you need to be. That's where I need to be.
Right.
So I always take 5 with me, and then what's an extra 2 pounds?
Right.
For the extra stick.
Good. So why don't we switch over to now the next, I think, sort of shift in what these sticks did versus what was going on in the industry, which is returning to a fixed step platform. And not only a fixed step platform, but a double step platform. So maybe Dan, why don't you talk a little bit about why you wanted to go in that direction and what really drew you to going back to that?
Well, the first thing was I wanted it rigid. I didn't want a moving part. Moving parts tend to make noise, they make creaks, washers wear out, the lock nuts wear out from moving. So I wanted something fixed, so it'd be solid, so it'd never make noise, and it would never have to be retightened, and I wanted it rigid. So the second part of it was, you get on a slanted tree, and you really don't want to step on the wrong side or whatever, and setting your stand and stuff, it's nice to have 2 equal feet on a platform. So what I did was I came up with a length I was happy with where you could fit your whole boot on it.
Yep.
And I made it so it set right into the stick, so it locked in. And then we make our tubes with a real specific tolerance, and we make our steps with a real specific tolerance, so they lock together. So there's no room for gap, no room for noise. And we made a certain angle that we felt was the best angle to fit any tree that somebody's going to climb, so that their foot's not sliding off. Now when you have a moving stick and it's buttoned up against a stop, there's going to be wear, and eventually that thing's going to be angling kind of down,
Yep.
and you're going to slide off of it and stuff. We also left a good ridge up here so you don't, and put real aggressive teeth on here to hold your foot.
Yeah, I agree. So a lot of those features that you called out were called out for ergonomics of actually being on the step when it's angled on a tree. So it's maximum safety and maximum usability. You know, you can actually take your full boot, your heavy rubber boots, and step across this, as Dan mentioned. Called out this extra raise right here that does prevent you from slipping, you know, when you're on the angle.
And you can put that on a 10-degree angle tree.
Yep.
On the side of it, on the angle side, and still be able to step on here without sliding off.
Again, going back to the purpose we were trying to fulfill, which was how do we get a safer, more ergonomically efficient stick for the type of hunting and the type of scenarios that we were going into. Dan talked about a fixed, strong structure. When he and I were originally going over this design, there were multiple versions of this. We had a flat 1/4-inch step with a single bolt. We tried that design both in engineering modeling as well as in the field, and we ran into issues with it.
Right.
That led us down the path of going to a 2-bolt model. And the whole time, considering how much weight are we adding versus how much rigidity, and eventually landing on this design with the 10-degree angle, the 2 bolts, and a slot, as Dan mentioned. That slot is important because that slot is what's toleranced very tight against this tube that creates that fixed structure when the parts come together. So that really gave you the step that you were looking for. And
Right.
I think the first full season that we used that double step modification, I think we were both saying this is a game changer. These are amazingly different from an ergonomic standpoint of climbing and just feeling safe when you're stepping on and off that stand and getting into angled trees. I mean, I wasn't feeling like I was sliding off the sticks anymore.
Right.
Yeah. So,
And really, that kind of led into the packability too,
mhm.
and into the design of the antler bracket, so that we could, into this design right here,
Yeah, why
we
don't you?
we could pack them together in line, where nobody else was doing in line. The staggered sticks were annoying. And especially to get to be a guy like me who uses 5. Pretty soon you got a pile like this, instead of straight up and compact, so we got them so that they fit nice and compact together, but still have enough distance from the tree, so that your boot ain't hitting the tree.
Yep. Why don't you talk about that a little bit, Dan? You've got basically a step here that you designed, which is in the shape of a Y, and you've got this aperture that's right here on the end that comes down, and it indents right here in this aperture. And
so I still wanted to have that slot go down far enough that it really seats this step. So I wanted to have this aperture, like you said, locking it in.
Yep.
But I also wanted this hole to connect not only this to the step, but lock everything together.
Right.
So it all screws together in line. So when the next one comes on there, it just goes right over the top of that with clearance for the nut.
Right.
So everything stacks in line and compact.
Yep. Now we often get asked, how do the B sticks stack? Do they lock in tight? Are they intended to lock in tight? And I think, what was the intent when we made these and how they stack, and really the reason why as you use them in the field?
Well, it's funny because you'll get guys that say if they're loose, they make noise. No, they don't. If you have them bungee down, they don't. If they're tight, they make noise. Try ripping 2 sticks apart when they're tight.
Yeah.
I've done it. You've done it.
Yeah.
We've done it on some prototype sticks. They're hard to get together apart without making noise. When they're like this, and I have them bungee down tight, they're not making any noise. And when I take them apart, it's just a matter of slipping one off.
Yeah. Yeah.
So it's just a matter of being quiet and going slow. And if a guy wants, he can put little stealth strips on the sides, or stealth strip the whole thing so he's not hitting it with a buckle or anything like that. But if you're careful, your noise going into the woods, and when you're stepping on leaves and breaking the branches and stuff, is way more than if you're carefully taking that apart and putting it back together. So I want it loose. I want to be able to just not have anything catch me by surprise and go snap or click or anything like that. I just want to slowly take my stuff apart and go up a tree because I'm setting up in close proximity to a bedded buck.
Right. So the reason why we want to call that out is there was purpose and intent behind that tolerance, behind the tolerance that the step actually fits within the antler bracket. There's a little bit of play in there, and that specifically was for that ability to, as Dan mentioned, slowly unpack and stack the sticks when you're in close proximity to that bedding area. So, on to probably, I would say, well, maybe I'm biased, but the coolest feature of the stick, the antler bracket itself.
And there's probably a lot more that goes into that than any other piece.
Yeah.
Because I really wanted it to look cool. And designed it to look like an antler, but still use computer models with diameters of the size trees we wanted to hunt out of, and made sure we hit all the points where they need to be on a tree for maximum grippage from very small trees to trees about like this, which is what we're hunting. And most of the time we're on edge and we're in small trees, but we wanted it to fit any tree you can get a strap around, if you can reach around it. So we went with a model of different diameters and made sure that we'd have good points on here. And then sharpened our antler points to the point where they bit in good. And there is nothing on the market that grabs a tree like this. But we did a lot of experimenting to get this design.
Right. There was a lot of experimenting between, as Dan mentioned, various radiuses of trees, as you're seeing on the sample there, which then impacts the distance that this arch has to be made, along with the height and distance of each one of these tines that are positioned along there. It wasn't just by chance that the design laid out by that. And then along the way, we were able to make a cool logo for the Hunting Beast and Hunting Beast gear.
Yeah. Which that was your idea.
Yeah.
And it was a good one. I like that, the look of that.
Another concept that Dan came up with post our first release was the idea of putting in a 45-degree angle on these antler brackets. Why don't you talk a little bit about why that's there and what advantages that has?
Well, what we get is if somebody puts a stick on loose, or if they hit an obstacle in the tree, and it slides down too hard and digs in on that corner, it could catch that and bend or break it, because then you're forcing where it's supposed to be. Your force is supposed to be going into the tree in a lever action.
Right.
But if it ends up that you're sitting on this, it could bend a bolt. So you don't want it sitting on a branch or a knot, or in the case of these angles, you want it to slide. So that helps it slide down the tree. When it slides down the tree, it locks in and gets super solid.
Yep.
So the slide really helped us get this thing so it was so rigid on a tree. Sometimes you pop it off a tree, you got to pop it out of the tree. Right. Because it digs in so much, and a lot of that's that slide that we have on that 45-degree angle.
Right. Yeah, that 45-degree angle really allowed people to lock the sticks in a lot tighter, and again, make a lot safer scenario for someone that was using the stick, because it would operate in the field better.
Another thing I had to change too is I really like the sharp stick. I liked it to just bite into a tree really, really well.
Yeah.
And people were getting cut.
Yeah.
So we had to dull that up a little bit.
We dulled them up and put some radius on there so that it
but they still work
sharp.
Excellent.
Yeah.
Another thing is too is we took that same thing that we did down here, is it locking into the stick so that it can't twist. Rigid. Correct. Locks in. Where other people were making them where they spin around and stuff, and then you couldn't get them real solid. Yeah. You know, and with the short sticks, everybody that was doing that was getting a problem with the bottom kicking out. Right. Where we're not getting that. Yeah. And that's a question I get often. Do your short sticks kick out? No, they do not.
No, they don't. Yeah, so the design feature that Dan's talking about there is, again, this slotting. This slotting mirrors slotting that's done on the step, but this slotting matches very, very tightly the tolerance of the sticks. And that allows to create a locked, fixed structure when you combine the step and the antler bracket.
And that brings up a good point. A lot of people watching this that follow us probably use stealth strips. And a lot of people are putting them around the whole stick. And I think these tolerances from the step to the antler bracket to the stick are tight and need to be. And putting something in between there is not a good idea. Right. So you need to cut around, if you use stealth strips, you need to cut around the brackets that you're bolting to your stick.
Yeah. So it's been interesting and complementary. We've seen a lot of change in the industry over the last 4 years.
That's a nice way of putting it.
Yes. So I think if you're out there searching products, you're going to find other products that have these design features and are now starting to look to utilize very similar features. We kind of take that as a compliment, and we're going to continue to innovate. So why don't we talk a little bit, Dan, too, now that we've got this stick up on our tree here, a little bit about the locking procedure. And I've got it strapped in now, as if you would initially strap it in. Why don't you talk a little bit about how you pressure on the top of the stick with your hand, and how you pull that bottom part of the stick out to really make sure it locks in.
When I put the stick on, I get it on the tree, I put the strap on perpendicular like that, pull it tight, get it as tight as I can by hand. I put a hand up here, put a hand down here, and I pull out on the bottom, and pull up, down on the top, and it goes on a little bit of an angle, locks in.
Yep. That slight adjustment in position movement that Dan made, and you'll see that that strap came down, is really it's a locking, a cam locking procedure that, again, when done, really increases the stability and the safety of you climbing the tree with the stick. And
when you step on, you can expect it to sink another ½ inch, 3/4 of an inch down, and just lock in.
Yep.
As you put your weight on it.
Yeah. But
another feature you didn't mention was the button.
Yeah, we were going to get to that, but yeah, let's talk about the button. Let's
Okay.
do it.
I thought you forgot about it.
No, but
Okay.
it's all right.
Well, a pet peeve of mine was the button that was currently being used by the other company that I used. I felt it was too big. It was hard to get a strap around it. And it was like an ABS plastic or a soft plastic. And there were a couple times when I got a strap on a little bit and broke half of it off.
Right.
Or I just dropped one or something and it would break part of it off. So we went with a really high grade type of plastic that's almost as strong as aluminum. Yep. And we actually machined these. So those aren't breaking. I mean, you almost have to try to break them. I'm sure somebody will break a couple eventually.
Yeah,
but,
and Dan, why don't you talk about too, from an engineering standpoint, why does that button have a sheath on it? It's a shaft that the bolt goes down through it, and what does that do for the strength of that button and that bolt that's in there?
Well, basically, all this button is doing is holding the strap in the right position. Probably 75% of the force on this is on the stick itself. It's not on that bolt. The bolt is just holding that strap in place, and there's a little bit of force as it pulls, but not nearly what's going into this stick, and that's part of that pulling this down thing, is really putting that force into that stick right there. And most of the strength is in the stick, and that's why we don't have the holes in that area.
Yep.
That's why they're removed from there, because that's the area that has to have the strength to support you.
And you talked earlier about kick out. There is specifics on what you got to look at for where that button is positioned, right?
Correct. When we do that with a computer model and put it exactly where it needs to be.
Yeah.
You know, you get outside of our realm, and it's really surprising to me, but most guys designing tree stands and climbing sticks aren't engineers. They're not. They don't have backgrounds in this, and I'm not knocking them. I mean, everybody wants to innovate and build stuff, but there's a lot that goes into getting things exact and getting them precise and making them really lock to a tree and stuff.
Yeah, and Dan and I mean, there's a lot of other people that have helped us and contributed to this from an engineering standpoint, from a manufacturing standpoint, that we've partnered with and worked with to be able to get these ideas to fruition. So it, you know, it's a combination of all those things that allows you to get a very innovative, safe, and industry-leading product out there.
Yeah.
Yeah.
I think if you get this in somebody's hands, it's over, because it doesn't look all that cool. It looks like a stick.
Right.
But when they put it on a tree and they try it, they test one of their friend's sticks or something, they're going to see the differences between these and other sticks.
Right.